Hi, welcome back. Here we are also tasked to solve for this given oblique triangle. In order for us to do that, we just need to complete all the needed measurements of this given oblique triangle. But we all know here that all side measurements are given. That would mean we are to solve for all the interior angles of this given oblique triangle. Now we have two formulas pertaining to solving oblique triangles. We have the law of sines and law of cosines. But for this situation here, where all the sides are given, this is an example of an SSS triangle. In this case, we are going to use the law of cosines. To solve this, let's first try to label all of these measurements. If we are going to call this a side A, if this is your side B, and this is your side C, we can label the angles directly opposite these sides as with the same letters. So if this is side A, this is your angle A. If this is your side B, that's your angle B. If this is your side C, this is your angle C. So again, we are to solve for the measurements of angle A, the measurement of angle B, and the measurement of angle C. Here, we are going to use versions of the formula of the law of cosine, which involves the determination of the measurement of an angle. But that is just for the first two angles here. We will just stick with the use of the triangle angle sum theorem in solving for the remaining angle measurement, so that we could really assure that what we are solving is a triangle. Because if we are just going to use the versions of the formula for the law of cosine for all the three angles here, we might notice later that the sum of the measurements of angles A, B, and C might be more or less 180 degrees. And if that's the case, our figure will no longer be a triangle, because a triangle, according to triangle angle sum theorem, all of its interior angles must sum up to exactly 180 degrees. So let's start with the measurement of angle A. We have formulas for this, including its derivation, but the formula here can be derived as this. We'll be using here minus A squared, because that's what's the intended angle there. This is a parenthesis. So this means this is B squared plus C squared all over twice BC. If we are going to extend a portion here later for additional computation, we could also write here for the measurement of angle B its formula using the same pattern. You have cosine, arc cosine, or cosine inverse. You will have your B squared as your last expression, and it's the expression to be subtracted from the sum of A squared and C squared, and your denominator would be twice AC, and that's your pattern. Now for the measurement of angle C, again, we will stick with the triangle angle sum theorem. Now let's solve for the measurement of angle A by substituting first the values there. Now you don't need to worry if you label this as B and that's A, that's C. Regardless, you will have the same result, because your measurements of angles will also be, or the label for angles will also be assigned in different vertices. So B squared here is 9. So you have 9 squared plus C is exactly 6. So 6 squared less 7 squared here all over twice 9 by 6. So we just need to input this in our calculator, and we could get the approximated value for angle A. Let us use this calculator is found an online calculator, and let's try to input first the numerator before the denominator. Later, we will just be applying the cosine inverse. But to do that, again, you just need to use parentheses to differentiate the numerator and denominator. I have 9 squared plus 6 squared less 7 squared, and close it. Divide by another parenthesis 2 by 9 by 6. That's 6. Close. That's your result, equal to. And that is what we will be subjecting to the arc cosine or cosine inverse of the answer. Equals to, you have this result, 50.977, so on and so forth. Rounding it off into 2 decimal places, we will have 50.98, or approximately 50.98 degrees. Notice that we use degrees as the unit of measurement for an angle. Let's move to the measurement of angle B using the similar pattern. So we'll have here cosine inverse. We will have a squared first, 7 squared, plus c squared is, you have 6 squared, less 9 squared. Notice the difference of the arrangement, over 2 times a, which is 7, times c, which is 6. Again, using the same online calculator, let us have this here. So we'll start with the parenthesis, 7 squared plus 6 squared minus 9 squared, that's for your numerator, close it, divide by, parenthesis again, twice 7 by 6, equals, and subject it again to the arc cosine or cosine inverse of the answer. And then you have here equals. So that's 87.270597, so on and so forth, or approximately in 2 decimal places, 87.27. So approximately 87.27 degrees. Again, you could use a version of this formula in solving for the remaining angle C, but there might be, I'm not saying it would happen in this example, but there are some instances where when you're done solving for the measurement of angle C, and when you're adding all the measurements of all angles, it may either be more than or less than 180 degrees, and that fails a triangle angle sum theorem. So instead of doing that, in solving for the measurement of angle C, we just simply use 180 degrees to be sure that it's a triangle, less those two measurements, 50.98 degrees less 87.27 degrees. So the measurement of angle C is not exact, but it's rounded off, so it's approximation. So you have here 180 less 50.98 less 87.27. Don't be confused with this. It has 2 decimal places, but because 2 of your values here, specifically 50.98 degrees and 87.27 degrees, are already rounded off, this is also approximation. Approximately 41.75 degrees. Now we are done solving. There are 3 different angle measurements for this oblique triangle. Before we go, we will use the hint that we had last time, saying that the side directly opposite the largest angle should be the longest side, and conversely, the side directly opposite the smallest angle be your shortest side. So for these 3 angles here, we have angle B, which is the largest, 87.27 versus this versus that. That would mean side B should be the longest, 9 versus 7 versus 6. And looking at the sides, 6, which is your side C, being your shortest side, it would support that the measurement of angle C, 41.75, is your smallest angle. This is how we solve this given SSS oblique triangle.